Hey, what's up, everyone? Today I'm very excited to start a new series on the channel, People Episode 1. People will be looking at scientists who, really, it will be looking at anyone I'm kind of curious about. But I was talking to a coworker the other day about world changing scientists, physicists, and I watched the Robert Oppenheimer movie recently, and I just kind of had thought about the collective advancement of technology. There's an idea called the law of accelerating returns, that is, technology, the rate at which technology develops is increasing because there is so much kind of backbone that's being built and structured around many smart people every day. So all of these beautiful devices and things that we're able to have access to so seamlessly are the result of years and years of work and advancement across many different fields and many different people. I'm really excited to bring this first episode in the series today about Joseph Fourier. Joseph Fourier was a mathematician and physicist born in Auxerre, and best known for initiating the investigation of Fourier series, which eventually developed into Fourier analysis and harmonic analysis, and their applications to problems of heat transfer and vibrations. The Fourier transform and Fourier's law of conduction are also named in his honor. Fourier is also credited with the great discovery of the greenhouse effect. So really neat. I studied him a little bit in college. There were a few courses that were very centralized on some of his mathematics and findings, and I was really grateful for kind of the work that he did and the insights he provided, as electrical engineers typically think about certain aspects of circuits in terms of frequency rather than time. And so, let's look a little bit about the biography. He was the son of a tailor, orphaned at the age of 9, recommended to the Bishop of Auxerre, and through this introduction he was educated by the Benedict Order of the Covenant of St. Mark. I guess that's some... let's investigate this. Right, so these are some sort of monastic religious orders. Interesting. So it's some sort of religious organization doing this backing. So we have some sort of Catholic religious doing this backing of his education. Commission in the scientific corps of the army were reserved from good birth, and thus being ineligible, he accepted a military lectureship on mathematics. He took prominent part in his own district promoting French Revolution. Interestingly enough, he was imprisoned, and interestingly enough, he accompanied Napoleon Bonaparte on his Egyptian expedition in 1798 as a scientific advisor, and was appointed secretary of the Institut d'Egypte. Cut off from France by the British fleet, he organized workshops on which the French army had to rely on for the munitions of war. He contributed several mathematical papers to the Egyptian Institute, which Napoleon founded at Cairo, with a view of weakening British influence. Interesting. And so this kind of, I guess, I didn't even know he was a part of these war efforts, but he went to Egypt, interestingly enough. Fourier never married. Very interestingly enough, in 1830 he diminished health. His diminished health began to take its toll. Fourier had already experienced in Egypt and Grenoble some attacks of aneurysm on the heart. At Paris, it was impossible to mistake with respect to the primary cause of frequent suffocations which he experienced. A fall, however, which he sustained on the 4th of May 1830 while descending a flight of stairs, aggravated the malady to an extent beyond which could ever be feared. Interesting. Shortly after this event, he He died on his deathbed in 16th of May 1830. Okay. He has a bronze statue erected in Auxerre. Interestingly, it was melted down for armaments during World War II. Joseph Fourier University was named after Joseph Fourier. That's interesting. Oh, this is really cool. So I actually went to France recently, and his name is one of the 72 names inscribed in the Eiffel Tower. I saw his name in the Eiffel Tower. It was really, really cool to see. It really filled my heart to see a name that I knew on there, and I knew a few of the names, but so let's look a little bit about his work. 1822, Fourier published his work on heat flow in the Theorie analytique de la chaleur, the analytic theory of heat, in which he based his reasoning on Newton's laws of cooling, namely that the flow of heat between two adjacent molecules is proportionally to the extremely small difference of their temperatures. This book was translated with editorial corrections into English 56 years later by Freeman. The book was also edited with many editorial corrections by Dorbeau and republished in French in 1888. There were three important contributions in this work, one purely mathematical, two essentially physical. In mathematics, Fourier claimed that any function of a variable, whether continuous or discontinuous, can be expanded into a series of signs of multiples of the variable. Though this result is not correct without additional conditions, Fourier's observation that some discontinuous functions are the sum of infinite series was a breakthrough. The question of determining when a Fourier series converges has been fundamental for centuries. Joseph Louis Lagrange has given particular cases of this false theorem and implied that this method was general, but he had not pursued the subject. Peter Gustave Lejeune Dirichlet was the first to give a satisfactory demonstration of it with some restrictive conditions. This work provides the foundation for what is known today as the Fourier transform. One important physical contribution in the book was the concept of dimensional homogeneity in equations. An equation can be formally correct only if the dimensions match on either side of the equality. Fourier made important contributions to dimensional analysis. The other contribution was Fourier's proposal of his partial differential equation for conductive diffusion of heat. The equation is now taught to every student of mathematical physics. Wow. So Fourier left some unfinished work on real roots of polynomials, right? This collective experience of learning, real roots to consecutive zeros of its derivative. He published independently his theorem. So he did some analysis there, or some work in roots of polynomials. And he also had a discovery on the greenhouse effect. Essentially that Fourier, he in the 1820s, Fourier calculated that an object the size of the Earth and its distance from the sun should be considerably colder than the planet actually is if warmed only by the effects of incoming solar radiation. He examined various possible sources of the additional observed heat in articles published in 1824 and 1827. However, in the end, because of the large 33-degree difference between his calculations and observations, Fourier mistakenly believed that there is a significant contribution of radiation from interstellar space. Still, Fourier's consideration of the possibility that Earth's atmosphere might act as an insulator of some kind is widely recognized as the first proposal of what is now known as the greenhouse effect, although Fourier never called it that. That is so fascinating. Like, even back in 1824 and 1827, Fourier, who was studying heat relations, discovered kind of inadvertently that the greenhouse effect. And if you're not familiar with the greenhouse effect, I'll open this really quickly, but it's essentially the Earth kind of warming itself with gases that are radiated and being insulated in the Earth's atmosphere. At least that's my probably dumbed down, ignorant version of the greenhouse effect. Right, it occurs when greenhouse gases and planets cause some of the heat radiated from the planet's surface to build up at the planet's surface. Shortwave radiation, things like this. if you want to learn more about the greenhouse effect, feel free to check it out. So now I'm just going to quickly jump into a little just fact checking with ChatGPT. And I really just have one prompt today. I feel like we jumped really well into the Wikipedia page about Joseph Fourier. As I hope to do with these scientists, I hope to really just bring some fact checking from the Wikipedia from ChatGPT. So let's go ahead and take a look. So our main question is, what are some interesting facts? Right, so we get some ideas about Egyptology, political turmoil, right? He lived in turbulent period in French history. Fourier's theorem, development of harmonic analysis, right? And then honors and legacies, the Fourier Institute, and Fourier crater on the moon. I don't know if there's a Fourier crater on the moon. There might be a Fourier crater on the moon. I'm only chuckling at that because we didn't learn that from the Wikipedia. Maybe I glimpsed over it. Heat conduction, right? Fourier transform, right? Fourier series. Yeah, that's pretty much it. Let me see if I can go up a little bit. Yeah, the study of heat transfer. Notice we didn't really get anything about the first. It doesn't really tell us about the interesting fact about the greenhouse gases, but it does tell us some other interesting facts and some things that we didn't know, like the crater on the moon. But yeah, that's all for this episode. I hope you enjoyed the first episode of people study. I think it's really important to understand where we come from as a society and some of the foundational minds that really contributed to the technological advancements to where we are today. That is Joseph Fourier, and this was the first episode. If you have any feedback or recommendations, please feel free to let me know, and have a great rest of your day. Goodbye.